Thank you for coming here. It's our great pleasure to welcome Professor Fabio Hernandez Palacio, the professor in City and Regional Planning at the University of Stavanger. He's visiting Chair of Housing Environment for the third time, which we are very grateful for. His research focuses on urban environments, on the quality of urban environments, and the role in creating better, more prosperous and sustainable societies. He also has strong experience in practice in urban planning related to accessibility, density, and urban design. We are very pleased to have this lecture of Professor Hernandez Palacio today. Please welcome.
Thank you, Patricia and Carolina, for the very kind introduction and for having me again here in Krakow, which is a city that I enjoy a lot. So as Carolina mentioned, that's the third time I have been invited as in this program as invited professor, but I also came the first time here for a conference like 4 years ago, so the last 4 years I have been visiting Krakow during spring. Doctoral candidate from Helsinki who is doing a PhD in Reykjavik in Iceland. And then this guy, a very interesting perspective, a very experienced person. He was a person that I read a little bit about the profile, used to work like probably around 20 years as a city planner. Was educated as an architect and then decided to do a doctoral degree, to take a doctoral degree. And then I was reading all his work. And then suddenly, I discovered that he was very much against that we call in city planning the compact city paradigm. And this, we will talk later about that. But this compact city paradigm is basically about, we want cities to be more compact, so things closer to each other, so to decrease car dependency. And of course, there are some trade-offs. And my main criticism to that doctoral thesis was that this guy didn't engage very well with the trade-offs, with the dilemmas. Because that's that we do, of course, in our lives, but very often in our professional everyday life. So that's why the title of the thesis and the subject of this presentation. So let's start clarifying what a dilemma is. A dilemma arises when competing values or goals force a decision in which gains in one direction produce losses in another. So you have to pay in a way. And it's not only in professional life, in life in general. If you decide to do one thing, you have to sacrifice another one. Let's say, the most common when you are young, okay, do I want to have children, for example? That's a big one. And then, yeah, nice to have children, but then you have to pay a price for raising them and living with them, 20, 25 years, or the other price if you decide not to having them, okay, solitude or other things, or a lack of purpose in life, or many other things. So life is not perfect, and it's like that also in your careers. So how to deal with dilemmas? And as Carolina said, my main thing with the students and is, I believe I am not able to teach anything, but if I am able that people keep asking good questions and they are able to ask the right questions, so I think that's the thing about. So mostly, I think the takeaways from this lecture in the end, I hope, is that you keep asking good questions and finding the right methods to answer those questions. And then eventually, you can manage how to deal with dilemmas. So dilemmas are addressed by first recognizing trade-offs, recognizing that if you choose one path, you lose some elements, you have to pay a price. And then you need to clarify values and priorities and explore alternatives and making informed choices while accepting that no solution is perfect. So here a first example, a career path dilemma. Probably you are very young, you are not yet facing that one, but most likely you will face that later on. Architects often face a career path dilemma between architectural design, focus on individual buildings and authorship, and urban design or city planning, which means broader engagement with the systems, policies, and collective spatial impacts. Well, many people stay in the architectural design path because in a way they offer you creative authorship, formal control, more immediate visual impact at the building scale. So you design your building, you present your plans, and probably in a couple of years, if you are lucky, you are able to see your building there standing somewhere. But often it limits influence on the wider scale. So you do your building and, well, that's it. Urban, you don't go beyond that. You don't have impact in a bigger scale, say. Urban design and city planning, in the other hand, provide a broader societal impact. So it requires a more strategic thinking, and you expect that you can influence and shape societies in a better way through regulations, through system changes. But of course, it involves reduced formal authorship. It also involves slower processes and political complexity. And well, the other thing that you may consider is the work environment. And that's very important because at some point you are going to know the price of whatever the track you choose. I mean, another one very common is that many of your teachers, they start working in as a practitioners in architecture, but many of them, they don't do that anymore. And mostly because of the environment in architectural design studios, which typically involve, you work for private firmas and clients, but it involves very short term delivery processes with long hours. Many people have to stay longer, especially when you have a deadline closing, even not sleeping enough and so on. That's very famous. Also, you are probably experiencing that here when you are a student. You also have to deal with close collaboration with clients that can be tricky because they don't understand the trade-offs. So they want it all. They want, but they don't want later on to pay your extra hours and so on and so forth. So it is a tricky environment. Well, if you work, on the other hand, as an urban designer or city planner, well, most likely you don't work for individual clients. You work for cities, you work for large consultancies. It's a little bit slower, so you don't have that those pressing deadlines. So you have a little bit more time. You have more control over your 8 hours of work and so on and so forth. But also, I mean, it's not easy either. I mean, you have to work with many interdisciplinary partners. You work with engineers, you work with environmentalists, you work with people who are from the social sciences, you work with politicians, and you have to navigate all the different understanding that those people have on whatever subject you are dealing with. And also, I mean, you have to work with citizens' engagement. You have to be a little bit more technical, to put a lot of numbers. So it is not exactly about, not necessarily about creativity in the way that you use in architecture. I mean, you have to use creativity in a different way. And we will explore a little bit how you do that. So the question, have you ever faced this dilemma? Anyone has faced this dilemma? Which year are you in your studies? Second year. All of you are second year. Well, yeah, you are still very fresh in this thing. So you still have a time to, but eventually you will face that dilemma. So, I mean, I will refer, I mean, how you navigate that dilemma. I mean, I think the first thing, of course, you need to have a good information. So let's say here some key skills that you may need as an architect. You need spatial and formal design thinking, so you need to be good with graphics, with representing things. Visual communication, also very good with how to present graphically attractive ideas. You have to know about technical aspects of materials, structures, and construction, how to build things, how to maintain them. If you decide one thing, okay, how that will look in 10 years, because some materials age very badly. They require a lot of maintenance. They look very nice when they are new, but very bad when they are 10 years old and not well maintained. For example, you need to solve problems through design. So, and design problem, I have a lecture about that, but the type of problems that you solve with designs are not the very clear defined designs. They are that we call weak problems. So they have many possible solutions. And you have to be good managing clients, especially if you work, let's say, designing houses or refurbishing interior houses or commercial shops or whatever. But if you work in urban design and planning, then you need a little bit different set of skills. You need to be able to system thinking and navigate different scales. Usually in architecture, you work, let's say, from 1 to 20 or 1 to 10, the detail of to 1 to 200. That's the range of scales that you manage when you work in architecture. In urban design, you work from the 1 to 200 to do some sections and so on in public space and some details in some public space design, but usually you work towards the larger scale, 1 to 500, 1 to 1,000, 1 to 5,000, even 1 to 50,000 for regional design. Yeah. So you have to navigate a broader set of scales. You need to know about policy, about planning law, and you need to understand how regulations affect what happens in reality. And you have to be quite good with data. And data, it's probably, I guess at some point you study geographic information systems. That's basically where city planners manage all the data, and that data can be quite complex. We will have some examples later. And you need to be good in mapping and have some understanding about research methods and so on. And of course, you need to deal with stakeholders, which in this case are politicians, also neighbors in an area where you are working. And you need to be able to manage strategic thinking. Okay, what if I decide this? What will happen in 10 years? Or to have those grand visions that engage people and so on. So as I mentioned, you may not be facing this dilemma yet because you are just starting, but it's good to know that those dilemmas will be there, waiting for you. And well, I believe that being a student is the period when you prepare yourself, acquiring the skills and the capacity to make, again, good questions and finding good answers to those questions, so you are able to navigate those dilemmas successfully. Well, this, initially I had the idea to have 5 dilemmas, but I had to reduce than to 3 because in the end they became quite complex and detailed. So it is about 3 dilemmas in contemporary urban design and city planning. And those are the 3 dilemmas. The first is compactness versus openness, density versus sprawl, and accessibility versus mobility. And I will say that those are the most crucial dilemmas that all city planners face everywhere in the world. And all politicians managing cities, they have to face them. So let's start for the first one, by the first one. Compactness versus openness. Well, let's first define the concepts. Compactness in urban design refers to the concentration of buildings, activities, and people within a limited area to promote efficient land use, shorter distances, mixed use, vibrant public spaces, and reduced dependency on private cars. So with all that promises, you may already guess that it has become quite a popular way of addressing city planning. So we want all those good things. There is a well-accepted understanding that compactness creates the condition for more sustainable cities in general. Openness, on the other hand, refers to the availability of space between buildings that allow access to sunlight, natural ventilation, greenery, and mobility, supporting fundamental aspects of urban well-being. And probably you recognize that drawing. I don't know if, how much have you seen from history of architecture, but do you recognize that sketch? Well, this is from Le Corbusier. Yeah. And this is one of the Unité Habitationale. And this dilemma between compactness and openness, I would say that is the origin of modern city planning. All city planning actually started because cities were too compact. And then all modern city planning was about how to make more space in between buildings. So exactly like this idea of Le Corbusier. So you have higher buildings and you have free ground floors with a lot of greenery. And I think you are familiar with some planning or neighborhoods from that period, and you know how it looks like. Yeah. So the first question is, of course, if we want to understand well what does it mean and what are the pros and cons of each of those, is that we need to know how we evaluate compactness and openness. So the most common indicator is this one, that is building coverage ratio. That's the other trick about those things. Those indicators, they tend to have different names. So you, in different papers, in different literature, you have slightly different names. That means exactly the same. Or very similar ones that we will check later. For instance, this one is the ratio of building footprints to open spaces. And it is of course, the indicator to measure this openness concept. So, meaning that you divide the plot, let's say you have the neighborhood area that you have to design, and then you divide the total footprint area over the total site of the area, and you get a percentage between, or a fraction between 0 and 1, or between 0 and 100%. Yeah. We will later check some examples, so you will get more clarity about what I mean by that. So the trade-off of compactness, and that's why they so badly the modern planners want to avoid too much compact cities. Of course, the advantages are land use optimization. So if you have things all close together, You can optimize infrastructure, and you can optimize space. You don't need to go very far to access services and so on, which is the second one, proximity between functions. So if you need, let's say, to go to the shop, you just need to walk a few hundred meters and you get there. Also, if you need to go to the school as well, it's not too far away. Also reduce the infrastructure length. Let's say you don't need to have very long electricity cables to provide electricity to the people. With the same cable, you can connect many people, same with pipes. If you want to collect the trash, you just have, let's say, you can centralize that in some places when people deposit the trash and so on. It's quite easy. You have a lot of active urban life. You go out and you see a lot of people. So cities lives quite alive. Also, that you have is, since you tend to have buildings close to each other, you tend to have very well-defined public spaces. So the public space is well contained between buildings, and it also creates those qualities that we appreciate a lot in public spaces. So I mentioned already vitality in public space. And the other thing is we have a lot of efficient use of energy. It's very well studied that if you put houses that are all together, or buildings or apartments, and probably you already experienced that, let's say if you live in a building and your apartment is surrounded by other apartments up, down, and to the sides, you pay less electricity in winter for heating because you have less loss of heat. But if you live in a house which is detached or whatever, yeah, there are a lot of, you lose a lot of energy, and so you have to pay more. So that's very well studied. Even if you have with the same materials, that's well documented. Well, the disadvantage, of course, is overcrowding. You may have a lot of always places where you want to visit full of people. If you do that badly, you might have, and it was the main issue, poor access to natural light. So to narrow things, some areas, old areas in Krakow or in many other cities, they don't have good access to natural light. Poor ventilation eventually. Conflicts between functions. You have nosy neighbors, bars or shops or people, and then you don't like that. Or as the modern city started, you have industries nearby that produce pollution, noise, vibration. So those type of conflicts between land uses is that I refer here. Weakened privacy, so you hear what your neighbors are doing, if they are fighting, if they are laughing, whatever, you can hear that. Noisy environment, you may eventually be affected by the noise from the streets, people having party, etc. And insufficient green areas. So you see, you have to choose between those things, and then here I have trade-off of openness. In the other hand, if you have too much openness, then of course the advantage is you have privacy. You don't live close to your neighbor, so it's okay. I cannot see him; he's far away. You can also separate functions, so you don't have problems with your next door neighbor having a party or a bar or whatever. Better access to sunlight, as the sketch I present from Le Corbusier earlier. Better ventilation as well. Quieter environments, since you don't have proximity between things. And more open space and greenery. And also enhanced domestic qualities, since you have more space, more natural light, more ventilation. Of course, the disadvantages is that you have longer distances to access services. So you have probably to go longer to the school or to drive to the supermarket. Longer infrastructure in general because things are more spread. So it is more costly to build and maintain those infrastructures. Less livable public spaces. So if you have those buildings separated, probably you have too much space in between, but nothing happening in those spaces. Larger domestic energy consumption, especially if you have those isolated houses. Well, also if you are a sociable person and you like to go out, nice cafes with a lot of people, probably you don't find that in the vicinity. And in general, also those things tend to produce more monotonous environments. Those buildings tend to be the same. Also the unifamiliar houses tend to be quite the same, and things are a little bit boring. So what can be the right middle ground? Is there a solution to mediate between those dilemmas? Any of you who wants to dare to propose or to get some possible ways to deal with that? Well, I will show you here some examples. And those are, first are two stream examples. This is Paris, I see this today. So this is very compact, and this is Brasilia, very open. So those are quite of stream examples. So in Paris, the open is just below 40%, and the build, the solid, is a little bit more than 60%. So this is that you get. And I make those estimations using Microsoft Copilot, so they can, Copilot counted the number of pixels in black and white, okay, estimated roughly that. So I believe it's close to reality. And in Brasilia, you have the opposite. Open spaces, 91%, and the build space is just 8%. And then you can imagine the qualities and all the issues and all the challenges, and you imagine being there as a pedestrian in those public spaces and so on and so forth. So you can imagine the consequences between those two extremes. Yep. Those are more middle ground contemporary urban designs. This is the urban renewal project in Carlsberg in Copenhagen. It is a renewal operation in an old Carlsberg beer, I think you know that one, a beer brewery. And there, the open spaces, this is not exactly white here, but also green and so on, is around 60%, and the black covered buildings is around 40%. And those are estimations made by my students in a course I teach in Stavanger, so I have to trust my students, but yeah, roughly about that, looks like that. So 60-40, think of that as a more balanced option. This one, in Borneo, Sporenberg in Amsterdam, a very famous project from the late 90s or early 2000s. I'm not counting the water here, so I'm only counting the open space, which is in land. And here it is the white, the open space, or also the green one in this case, is around 54%, while the black or the built is around 46%. So it's close to 50-50. Yeah, but of course, I mean, in addition, they have all the spaces, the water spaces that creates more openness sensation. And this one, the Western Harbor in Malmö. This is like 30-70, a little bit under 30. And well, I like this one. It's a little bit more towards the low density thing. And it is, the build is around 28%, the buildings, and the open void is around 71%. And here I am not counting the water. Water is the black thing here, and this one is also a canal. I'm just counting the areas that you can go walk in. Okay, that was the first of the dilemmas we had to evaluate. The second one is density versus sprawl. Well, many people kind of confuse or overlap, and indeed they are overlapped, density and compactness. But I mean, as you saw, compactness is about putting things together, but density is a little bit more complex. I will explain that later, but density is more a multidimensional concept, and is measured by several indicators, and to really understand, especially build density, you need to combine them at the same time, otherwise you get lost. You saw that the compactness, you can in a way only measure footprints and you get a good grasp of compactness, not for density. Urban sprawl is the expansion of cities through low density spread out developments that separates uses and increase land consumption and travel distances. So it's basically when we want to live outside in villas, like houses, shopping malls connected by highways, and so that's sprawl. And we have a lot of space in between buildings. So how we evaluate density and sprawl so we can make decisions better informed about those two issues. Have you seen this image before? What do you think is the densest? This one. This one is densest. Okay. Any other idea? The middle one. Okay. And nobody says this one? Well, they can be, all of them could be the densest in a way, but all of them have 75 houses, or if we can count of those little blocks, so that's say number of boxes in all of them. But they have different footprints, and they have different heights. So you can say that this one is the densest because all of them are concentrated in just one point. But of course, that's the tricky part. I mean, density is as well. Of course, the container here is this square. So if you compare that to the square, is probably the same density. And here we are going to explore a little bit how can be complex to measure urban density. But that's also very important that you understand that, because that's the way you may interpret regulations where you have to design things, and how you can take advantage of those regulations to make the best of your possibilities in your architectural designs as well. Here we have a very interesting study. Those are two authors that did probably 20 years ago, 15 years ago, a very famous doctoral thesis in TU Delft, and they developed a tool that they called SpaceMate, and it's how to evaluate density and typomorphology. And here is a comparison between 4 areas in the Netherlands. I think all of them are in Amsterdam, different neighbors in Amsterdam. And here are the neighborhoods, and here are the different measures that they evaluate. So the first thing that they evaluate, well, we can start by the easiest one, which is heights, so the number of floors. That's of course one aspect. We can go to open space ratio, which is different to the openness that I mentioned before, because in this case is, of course, the non-built area, space area. This is one component, but the other one is the total gross floor area of all buildings. So meaning that if you have different layers, all of those, you have to count all of them. Not only the footprint, but the different layers in the building, the different floors. So it's the total built area against the open space. The other one, the first one was only the footprint. So you see the difference, and you see how tricky it starts to to get. Then you have this other one, which is gross space index. They also call it, some other people, other area, they call floor area ratio. So they have different names. That's the other tricky thing about those indicators. Gross space index is the total building footprint, so built ground area, over the total site plan. Yeah? So it was a little bit more similar to the one we had. And then we have this floor space index, which is the total gross floor area of all buildings over the total site plan. So this is to open, and this is to all the total site plan. Yeah? And that's why when you start dealing with regulations and you have to develop a site, so the plan that you read, they will probably give you this one. So, and that's the problem with regulations, that they don't control, for instance, height in many cases, or they don't control all those things. So that's why, and as you see, you can have very similar densities as we saw in the previous example, then the same number of houses in 3 very different shapes. Because usually the regulations, they don't control for all those indicators at the same time. They just usually choose one, which is this one. And that's that, and with that one, I mean, of course, you have a lot of freedom in the way you put your buildings and so on, but also the danger is that you lose a lot of quality. So density in urban design is a complex and relational concept that describes how people, buildings, or activities are concentrated in space, and is not defined by a single value, but by a multiple indicators whose meaning depends on the size of the container. That's the other tricky part. I mean, you can measure different densities, but they will change depending, let's say, if you measure to the neighborhood, to the city, to the region, to the municipality, etc., to the plot, they drastically change the density. So indicators such as population density, dwelling density, floor area ratio, building coverage ratio, and employment density capture distinct spatial, social, or functional aspects of urban form. But crucially, density is scale dependent. So the same number of people or building can appear dense or sparse depending on whether the container is a plot, a block, a neighborhood, or the entire city, making density a relative and contextual measure rather than an absolute one. I mean, that we do, of course, to avoid that is that we say, let's say, people per hectare or per square kilometer. But of course, that's also problematic in some other ways. So whenever you read the density of something, be aware of what the limit is. And I have some examples. So why does the dilemma between density and sprawl matters? Well, the density sprawl dilemma matters because it shapes how cities consume land, use resources, organize mobility, and produce everyday quality of life. And it forces planners to balance efficiency, sustainability, and social proximity against space, privacy, and perceived livability. So there is a lot of tensions there. I mean, because let's say many people have the dream of having a big house outside the city with a green area around, with gardens and so on. But many people is not aware of the costs involved in that, or not only for them as owners, but for society in general, for example. So there is a big debate about density and sprawl. Well, in my research and in my exercises teaching urban design and city planning, I came to at the conclusion that a range between 50 and 150 dwelling per hectares is kind of the middle range in which you manage to get enough density to afford services without having too much overcrowding and too much problems. So of course, if you are towards the lower end, 50, yeah, you still have a little bit of blocks, low density, probably, or even villas with small gardens, but not really sprawl in the way that you don't afford to have, let's say, a good public transport system or other services. Of course, I mean, how we accommodate those things and how we do that with quality depends on the abilities you develop as designers. So here is many of the dilemmas that many cities face. I mean, many cities, especially cities in North America, they tend to have quite high-rise buildings with offices and things like that, of very compact cores. And they go directly to very low densities, and there is nothing in between. So what is the scale in between so that you create a smooth transition? Or what is this middle ground between very high rise, this type of density, and very low density? And I think that's the range I mentioned. And well, this is a work, this is some graphics from this book called Soft City from David Sim. This is mostly about that. It's about creating possibilities to urban design that address this middle ground. So those densities that I mentioned between 50 and 150 houses per hectare, how you combine them and create enough diversity, enough possibilities for many different types of users, and urban designs that can be adapted when societies changes, which are indeed happening every day. Okay, here are some trade-off of density, especially density when it's addressed by those indicators that we evaluated earlier. There are some advantages of having high floor space index and balance it with gross space index and open space ratios. I mean, if you manage to balance that right, if you manage to be a good designer, a good architect that are able to put together well those numbers, you can have a lot of advantages. Of course, the first thing is that all developers, people who is investing in real estate love, is that they increase the floor space index. So more floor area per hectare. So they will sell more apartments, let's say, if they get permission to build a project. They love that. Of course, if you do that right as well, you can support public transport. I mean, one of the problems with sprawl is that many cities that have low density, they have to subsidize public transport, because since people live so separated, the frequency of buses and trams or whatever, they cannot be very often. So many people is disencouraged to use public transport. But if you have people living together, of course, you don't need to subsidize public transport. It can be self-sustained by the tickets that people buy. Of course, you have advantage if those high densities are well designed, is that it facilitates shorter distance and walkability. So people can go to whatever destinations they need every day. Also, if you do that right, with good design, you can create a good functional mix. So you can live close to shops, supermarkets, you can even combine parking without having blind facades towards the street and killing the livability of the streets. And as I mentioned earlier, you can have greater infrastructure efficiency per capita. With the same meter of pipe that you serve, let's say, 2 or 3 people in the suburban area, you can serve hundreds of people in a more dense area. And also if you manage to combine that right, so high floor space index plus controlled gross space index plus sufficient open space ratio, you create this quality that we all want to have, at least in the urban design discipline, which is urbanity. This livability in cities, this quality that those qualities that we enjoy when we visit cities. Well, the disadvantage if we do that poorly is that we create a lot of pressure on open space, so we don't have enough open space to attend the amount of people living in a given area. We risk to have poor access to light and ventilation. We also risk to have overcrowded spaces or facilities or services. We eventually can induce heat islands in summer because we don't have enough greenery. We can, in general, develop a stressful environment with a lot of noise and a lot of overcrowding. And it is, of course, highly dependent, to do that right, is highly dependent on design quality. So we need good urban designers that are able to understand all those things and put those things in the right balance. For the other side, the trade-off of sprawl. Of course, I mean, being so popular is because there are some things that people like to have. That's why so many people want to have those houses outside the cities. It's because they perceive that they have high open space availability, even if the space is private and they cannot go there. People think that they have more space anyways. In general, houses outside the cities, they are larger. Surely they enjoy greater privacy since they are living separated by gardens, and they have also this sense of exclusivity. So I don't need to share much of my everyday life with people. And for sure, since you don't have that proximity, you tend to have more quieter environments, especially if you don't need close to the highway. The disadvantages, I already mentioned some of them, is inefficient land use. So you have a lot of space that is, in a way, not properly used. Let's say buffer space to separate the highway from the houses and so on. You tend to have longer commuting and car dependency, since you cannot afford to have enough frequency of buses. Also, you probably need to have several cars at your house for these people working, for example. Longer commuting as well. You need to go every day to work and probably long time, waiting queues, etc. You have functional segregation, so meaning those areas are just houses, and if you want to go to the supermarket, you need to drive. You have a weak urbanity, meaning that you go out through your window, you don't see anybody, you feel that you are not really living in a city. And of course, all those things together create increased housing costs. I already mentioned that those things are less energy efficient, so your electricity invoice is higher every month. You have to maintain the cars that are not cheap. You have to use extra time to go to X or Y places. So in general, it is more expensive to live outside than in a house outside the city than in an apartment inside the city. Well, the third one is accessibility versus mobility. And this is, of course, I mean, all of them, you will find that there are a lot of literature and a lot of scientific papers about all of those three dilemmas. Well, accessibility, of course, we need to define that and to be clear what we're talking about. Accessibility refers to the easy of reach destinations, emphasizing proximity, spatial organization, and the distribution of activities rather than the movement in itself. So it relies heavily on proximity. On the other hand, mobility refers to the ability to move fast in the space. So you can cover more space in less time. And for that, of course, you require motorization. So in this case, this performance requires, of course, more space, because, I mean, if you want to move fast, you probably have noticed as well that if you you drive in the highway, probably you have seen that the lanes are wider. But if you want to go to the inner city and the lanes are narrower, you need to go slower and so on. So it needs more space, for example, the infrastructure. And you rely in the capacity of this infrastructure. And basically, you count mobility as the performance of those transport infrastructure, roads, railways, etc. So how do we evaluate accessibility and mobility? Accessibility indicators are reach, so how many services or facilities I can reach. Let's say you probably have here of the 15-minute city. So how many shops you can find within 15-minute city walking from your house. Opportunities, of course, I mentioned they were involved in that indicator, and proximity. So those things are the ones that you need. And here is a typical city network that has a lot of accessibility. So you can go from A to B in many different ways. So that's accessibility. Here is mobility. Mobility indicators are usually speed, flow capacity, so how many cars can pass by this road, congestion, so how long are the queues, or how long I can go in 1 hour or in 10 minutes or whatever, and network performance, so how much cars can accommodate a given network. And usually the design is more like this. You have those highways with those spaghetti things to keep people moving, and then you have neighborhoods that are mostly like that. They are like islands. So you can imagine that going from this one to this one, you only have one chance. So it's not like this one that you have many opportunities, many different ways to go from A to B. You have probably one or two, and that's it. So that's the design for mobility. So let's say that accessibility is about people. So how we provide access for people and mobility. And here I will explain a few measures of both concepts. So how we measure accessibility. The first one is cumulative opportunity accessibility. And it measures the number of meaningful destinations that can be reached from a given location within a specific travel time, distance, or cost threshold. So the cost is usually time. Here is an example of one of the research that we do. And this is a paper that we did in Stavanger about accessibility to grocery shops. So basically to supermarkets. So we wanted to know how many supermarkets can people reach from basically every house in Stavanger. So here we took one example, one area of the city. Those yellow points are the supermarkets. And let's say you have this supermarket, and if you walk 10 minutes, that's how many houses are there. So everybody living within this perimeter can walk to this supermarket in 10 minutes. Yeah, and of course we rely on the network, which is the yellow lines. So you get there in 10 minutes. Then, of course, if you start having more, then you have to overlap them, and then every minute, for instance, these people here, they can reach 2, these people here can reach 3, and these people here can reach 1. So I think that's clear enough. Yeah. Then we use a geographic information system to calculate this cumulative. That's why we call cumulative, because it's one over the other to calculate this cumulative accessibility. Oops. And this is the result. So here is cumulative accessibility for, in this right one, is cumulative accessibility for people by foot, and here by bicycle. Of course, by bicycle you go faster, so you can reach more. And the results are here. I mean, the most densest area in the more central spots, you can, the darkness areas, you can reach more than 25 grocery shops between 10 minutes. And of course, in the periphery, you can reach just 2 or 3 or even 1 in some areas. So that's a typical cumulative accessibility map. There is another way of measuring accessibility that probably you are familiar with, or you will get at some point familiar with, which is relational accessibility. I mean, it's very famous, measured by this, by space syntax. It's a very well-known methodology and a very well-known theory. And accessibility is measured by how spatially close and connected places are within the street network, and it uses measures such as integration and choice rather than distance or speed. So I will explain a little bit later. For instance, this one is about schools. So those are schools, and is mostly about how easy it is to get to schools. Not how far schools are, but how easy it is to get to schools. So, and this basically count how many turns you have to, how many changes of streets you need to do to get to the school. If you need to do 1, 2, or 3 changes or more. So if you need to do more, it's more complex. If you don't need to change street, it's easier. But it's not about the distance. It's about the relations between those. Okay. So it's like here. Let's say 1 step meaning you don't need to change street. 2 steps, you need to change. You need to use 2 streets. 3 steps, you need to use 3 streets. And then, I mean, like this one here. So 0 streets, so you need to change 1, 2, 3, 4, 5. So meaning that if you live here and you need to access something here, this is much more complicated. It's about complexity. And it produced these very nice and visually maps and many different measures of how complex it is to get to services. So, and this also describes a little bit, in a way, they tell a little bit a similar story to the other one. So you can imagine that those areas here, if you want to put a successful bar or a successful business, where you will locate that? In the red or in the blue or in the green? Red. Yeah, in the red. Yeah, those are the better located, better integrated areas in the city. So basically this describes centrality, as did the other one. Also the darker areas in the other ones where more shops are, they are the centers of the cities. Yeah, also because they are better integrated into the system. Yeah. Okay, mobility. As I mentioned, mobility is about speed, it's about cars. It's not about people. You see here, this is a very nice picture, no people there, no possibility even for people to access buildings. We just care about cars. And that, of course, is a very frequent dilemma between planners. And we have 2 types of planners. I remember when I started working, I started working like 30 years ago, getting old. And then I started working in Colombia. I'm from Medellin, Colombia. And it was a very well-known consultancy, small consultancy firm there. And it was, they were partners, they were architects, and initially were architects and transport engineers. And they have very interesting debates because, of course, at that time, the engineers, they were only planning for cars. And of course, really doing those, the problem was how to get fast from A to B. not how to provide accessibility. So it was very evident this dilemma and this tension between the two. And here there are some indicators how we measure mobility. This is a very famous one. There's even ranking, universal ranking, the TomTom traffic index. They measure basically, you know what a TomTom is. TomTom is, well, probably it's not that popular anymore, but it was before we had Google Maps. We had a device before again, I'm getting old. Before we had them, you all grew up with mobiles. But I still, I grew up in the time when we had to ring from those big orange boxes and so on, and just to make an appointment. Yeah, I see you tomorrow at 3 o'clock, and you don't have ways to communicate with that people anymore, and you have to trust that they will come. But anyway, in between that, it was a small device that it was called TomTom, and was basically like Google Maps, but what just was for that. And then they create those maps from all the world, and they still, I think they create still the algorithms and all the things, and probably they are embedded in Google Maps and somewhere else, because that's the way they measure how fast cars move in cities. So then create this index, which is the TomTom traffic index, and is how how fast cars move in a city. And here they are comparing Mexico City, Bangalore in India, and Dublin in Ireland. So you see that the worst is Mexico City, because to get around crossing the city, let's say from A to B, if you don't have congestion, let's say Sunday 3 o'clock a.m., no cars there, you can do that in 1 hour, 57 minutes. But in a real travel day, you get much more time. So this is travel time per 1 kilometer per minute. So no free flow without stopping, 1 minute 57. But real life, 3 minutes 27, and so on. So you see the difference comparisons. And that's how those indexes get developed. And of course, they reflect, for some people, they see it as a big advantage. Okay, if you have too much congestion, it's too bad. But yeah, well, to get there, to have more space for cars, you need to sell other things. You need to sacrifice many other things. And here is another map, which another way of measure mobility. This describes Switzerland or the entire country. And it describes the mobility network, revealing how movements concentrates in the different cities and how dense is this flows of cars. So it's about mobility flows. So there are different ways of mapping and measuring mobility. But usually they concentrate in single aspects and they neglect the other. So to understand reality, you need to use, in a way, both. So here are some trade-offs. The accessibility-mobility dilemma contrasts reducing the need to travel through proximity with increasing the ability to travel through speed and infrastructure. Of course, improved accessibility prioritizes bringing destinations closer together, while improved mobility prioritizes moving faster across longer distances. Improved accessibility depends on density, mix, and spatial organization, while improved mobility depends on efficient transport infrastructure. So broader networks with a lot of those spaghettis that nobody enjoyed that, not even the people driving, only when they are driving fast. Improved accessibility reduces travel distances because you can go very shortly to wherever you need to get. But improved mobility usually induces longer travel because you improve mobility by spreading things, separating things. So you can go faster, you use less time, but you have more distance in between. Improve accessibility, encourage compactness, while improved mobility enables sprawl. It's the other way, it's the opposite. And making distances less costly. So you can, less costly in this case is time. So you can get longer in less time. Improve accessibility strengthens local street and public space. But improved mobility is about uninterrupted movement and network capacity. So those are the dilemmas that you need to mediate when you deal with how you move people in cities. Well, it has been a long lecture already. I have been talking here more than 1 hour, but this is the last slide. So I would like to conclude to say that urban design is the art of navigating trade-offs. So there are not perfect solutions. Whatever solution brings new challenges. The role of the designer is to propose evidence-based proposals that can adapt over time, because cities will keep changing, people's needs change all the time, and that's it. I mean, that's the trick and the complexity of urban design and city planning. Thank you for your attention.